Okay, real quick, I'm going to go over number 2 and number 3 because I saw that number 2 was had the wrong answer, so we'll see what happened there. All right, so real quick, as number 2, 100 milliliter bubble. So as soon as I see milliliters, that's going to be a volume, and that's my initial volume of hot gases at 225 degrees Celsius. This is my T1, but I have to add 273 to that. I have to put it into Kelvin. That's just what they have to do in chemistry. So that's 498 Kelvin. That's the number I'll use. And 1.8 atm. So there's my pressure 1. It escapes from an active volcano. What is the new volume? So I'm looking for V2 of the bubble outside the volcano where the temperature is -25. Now I've got to add 273 to that to get Kelvin. And that is going to be 248 Kelvin. And that's my new temperature. And my new pressure is 0.8 atm. So now I'm going to plug it into the equation from yesterday, and that is P1V1 equals P2V2. But then we combined everything, so we ended up adding our temperatures underneath. So it's P1V1 over T1 equals my final pressure times my final volume divided by the final temperature. So I'm going to plug in 5 of these numbers into these spots. So let's look at my P1 is 1.8. My V1 is 100. Now I could have flip-flopped these. I could have said 100 times 1.8. It doesn't matter. I'm going to divide by my T1, which was, remember I'm using the Kelvin, 498. Now I'm going to go over here, and I don't know my V2, but I know my P2 is 0.8 times V2. I don't know what that is. And my new temperature, remember I've used Kelvin, is 248. All right, so once I have that set up, I'm going to cross multiply. So I'm going to multiply these 3 numbers, the 1.8 times 100 times 248, and that will give me 44,640 equals. Now I'm going to multiply these. So 0.8 times 498 is 398.4, and of course I still have this V2 right here. So now to get rid of, to get V2 by itself, I'm going to have to divide each side by 398.4. And my V2, once I do that, that cancels, that crosses out. So once I take 44,640 and divide it by 398.4, you should get 112, and it's a volume, so it's milliliters. Okay, so that's how you do that one. I haven't had a chance to really look at yours too in depth yet. I just saw that the overall answer was off, so I wanted to make sure I hit on this one too. So yeah, it's just in the previous sections, we only dealt with 2 of these variables and the other one stayed constant. Well, now I'm like, okay, well, what if I have a balloon in the classroom and I press on it, so I'm adding extra pressure, but then I also heat up the room at the same time. So what happens when all of those come into play? And a lot of times that's what's happening, like outside with tires and all that, usually there's pressure, volume, and temperature all happening at the same time. So most of the time it's combined gas laws, because we have a really hard time of keeping something constant. All right, so let's look at number 3. Number 3, I think this one is a little bit harder because it does give you an extra number that you don't need. So that was probably the issue here. You had this 40 feet. Now we have never dealt with feet when we do pressure, volume, and temperature. There are no feet in here. So they're giving you a number that means nothing to you. So it's just telling you, it's just giving you information that, hey, this diver is 40 feet below the ocean surface. This number, though, I will not use. I don't need. So he inhales 50 milliliters, so that is my initial volume, what he's got, of compressed air in a scuba tank at a pressure. So here is my P1. And the temperature of 8 degrees, there's my T1. But remember, I'm going to add 273 to that. So that ends up giving me 281 Kelvin. So I'm going to go ahead and plug this in. I've got P1 is 3. My V1 is 50 divided by my temperature. My initial temperature is 281. All right, so now let's look at the rest. I'm going to do a different color for that. What is the pressure? So that's what I'm looking for. What is my P2 of air in the lungs if the gas expands? So there's my V1, my milliliters, 150 milliliters, at a body temperature of 37. Now remember, I'm going to add 273 to this. So that is 310 Kelvin, and that is my T2. All right, so let's plug these numbers in. I do not know my pressure. I do know my new volume is 150. Here's the big thing. I'm just checking. Every time I do this, I check to make sure they're in the same unit, so I'm good. And then I'm going to put my temperature down here on the bottom. All right, so now I'm going to cross multiply. I'm going to take these three right here and multiply. So 3 times 50 times 310 is 46,500. Then I'm going to take these three and multiply. So 281 times 150, and of course there's my P2. So this ends up being 42,150, and then of course I've got my pressure that I don't know. So then I'm going to divide each side by 42,150. So this cancels out, and it leaves my pressure at 1.1 ATM. Now I know it's ATM because that is what they gave me. Let me find it right here. All right, so if it would have been if they would have given me my pressure in millimeters of mercury, then my answer would have been in millimeters of mercury. So anyways, I hope that helped out. If there's anything else that you need, let me know, because we're going to be wrapping this up soon. We're going to be doing a review, which I'll put the video up of the review. And then we'll have like a short, like a quiz test, a quest kind of. It's a little bit bigger than a quiz. And then we're going to move on to some organic chemistry. I want to make sure that you guys do get that before we get out of school for the year. So if you need anything else, let me know.